Thank you. Maybe we can pretend we're in a panel discussion after your wonderful lecture.
All right.
I think one thing that people are interested in is why you use the term dark microbial matter, and why is that important in relation to what you're saying? And is there anything else that term from physics, borrowed from physics, can tell us about the future, or a way we need to change how we think?
So dark matter in physics is this hidden material that we can't see. We know it's there, but we can't really characterize it. And in some ways that's exactly the situation with microorganisms. Microorganisms are incredibly diverse. We understand only a small amount of their diversity. We understand even less about their gene diversity, and even less about what those genes are actually doing. So dark matter, to me, represents that lack of knowledge. We understand there's known unknowns here. We know that there's a whole bunch of things that we don't know. And for me, that's what dark matter is. The other thing about this is that microorganisms, because they're small, never kind of make it into our everyday consciousness. Exactly. They're just in the background somewhere. And so we tend to dismiss them because we don't interact with them at all.
Mm. You know, it's very interesting what you said about this, that the biomass of humans and domestic animals is now 35 times that of wild animals. Is that what you said? Yeah. So, has that proportion has also must have changed in relation to the overall biomass on the planet?
Yes.
So, if it's finite, the biomass on the planet, that means we as humans and food we like to eat, has changed all the other species into ourselves. Is that right?
Yes, that's absolutely true. You could think about it this way, that the amount of energy hitting the planet is constant because it's sunlight, essentially. Everything on the surface of the planet eventually relies on energy from sunlight. That energy from sunlight can only be harvested by photosynthesis in plants, and that fixes carbon, that supplies both energy and matter for animals to eat. So it's likely that the total biomass on the planet has remained pretty constant for, I don't know how long, a long time, much longer than the period of human evolution. What that means is anytime any organism increases its biomass, its relative biomass, its slice of that pie, it must necessarily decrease the biomass of something else on the planet. And we know this because I think the estimates suggest that humans use 20% of gross primary production, and we certainly use 20 to 25% of the freshwater resources on the planet. So anytime we do that, we have to think, you know, if there's 7.6 billion humans, that means that that amount of weight of other animals can't be on the planet. It's just as simple as that.
So, if we've gone from 2 to 7.6 billion in 100 years, how do you explain why that explosion in population happened? And is both global warming and antimicrobial resistance a consequence of the same processes that led to the human population explosion?
So, to step back to ecological principles, usually what happens when you get a bloom of an organism, you get lots and lots of one organism in one place at one time. Two things step in to limit the population growth or maintenance of that organism. One is disease that gets into the population and just wipes them all out. The other is you use up all your resources and everything starves to death. Humans have sidestepped both of those restrictions.
Mm.
And we have done so by tapping in to fossil fuel energy that allows us to produce huge amounts of food at will, and we have sidestepped control by disease by lots of different things, by modern medicine, by hygiene, by antimicrobials, all of the things that we do. So those two things mean that we are unique in the history of the planet, that we are able to continually increase our population. Now, whether we can continue much longer is not certain at all. But we know also that in order to have everyone on the planet enjoy what I would call a healthy, equitable life, we probably can only have 1.5 billion people on the planet, maximum.
Okay, now let's go to a tough question. So, in working with antimicrobial resistance, the guidelines for global action and country action and action by ordinary people is a set of strategies such as hygiene, such as reducing the use of antibiotics in both ourselves when not needed and in our food-producing animals and in agriculture generally, and looking for new antibiotics, and a whole system of monitoring resistant genes so we know what's happening in our own particular locations. But when you look at it from the point of view down there at the genetic level, as you've explained to us, in this dark microbial matter, do you actually think that these strategies are likely to make any difference?
That's a really interesting question. So again, I'd step back to the high-level question. So antibiotic resistance in some ways is really similar to global change in that it doesn't respect boundaries, that it requires cooperation and integration across political and social boundaries, that it differentially affects the poorest people on the planet, that it is, again, the classic example of private versus public good, so that privately, I want myself and my family to be healthy, we're going to use antibiotics to do that, but in terms of public good, that is not so fantastic because I am likely to then generate resistance that is going to kill other people. So the parallels between these global problems are absolutely real. Now, can we actually overcome antibiotic resistance? From an evolutionary point of view, I don't think it's possible. All we can do is slow the rate at which antibiotic resistance appears and spreads, because bacteria have 30-minute reproductive cycles, and their potential rates of realized evolution are enormous, so that we can't really expect bacteria to stay the same in the face of us trying to control their growth. The best we can do is hope to lengthen the period of time that any one strategy will work. It is possible that you can cycle strategies so that you can use a particular strategy for controlling bacterial disease for a while and then stop that and do something else. So the strategies would be things like antimicrobial use, as you say, hygiene, vaccinations, phage therapy. They're some of the possibilities.
So over time, if we can, let's just take the reducing antimicrobial use drastically to just what we need for ourselves and for really sick animals, and if we change the hygiene of how we produce animals and change our diet, over time, you think that we can begin to take the pressure off our ecosystems, and the ecosystems themselves can I don't know if recover is the right word, but there seems to be a really drastic reduction of diversity going on in the microbial.
What we have to think about here is stewardship of the planet. From my point of view as a biologist, I don't think that there's any part of the planet that isn't influenced by human activity. I think we have to accept that, and we have to say, well, if the world is actually mainly dominated by human activity, we have an opportunity. We have an opportunity to make the planet the way that we would like it to be, rather than waiting for things to happen and force us into a future that we're not happy about. So one of the problems here is that it's really difficult to predict where tipping points are going to be. You don't really know that you've reached a tipping point until you tip over it.
Yeah.
So there's a huge problem, and lots of people are thinking about what these tipping points might be and whereabouts, you know, how far can we push it until we go over the edge. But we need to pull all of those phenomena back as a precautionary principle. So the original question was about whether we can maintain antibiotic use in the long term. Certainly there are things that we can do. Everyone could eat less meat because there's a lot of antibiotics used in meat production, and meat production is environmentally expensive. We can certainly stop using prophylactic antibiotics in food production, because, you know, for a long time antibiotics have just been used to gain increases in growth rates and final weights of animals, for no reason other than that they do that. Antibiotics should be restricted, as you said in the question, to treating sick animals and preventing the spread of diseases across lots of animals. And the same for humans. We need to use antibiotics much more rationally, and we need to accept the fact that, for instance, there are some conditions for which antibiotics are routinely prescribed which don't need antibiotics. I mean, viral diseases are a no-brainer. You just don't need them for that. But there are other things as well, like ear infections in children, for instance. They're inconvenient, they're painful, but they eventually clear up without antibiotic.
So, therefore, if we think about what you were saying about how microbes and microbial genetic elements travel, therefore we also have to really think about and take care of our soil, our water, the air. So all the things that can increase the health and the diversity of the microbes in the soil and in the water. So we have to change the way we think.
We do. We're at a critical junction here where we have enormous power. We have enormous power to track organisms and genes around the planet. We also have enormous power in terms of remote sensing, satellites, prediction of various biogeochemical, climatic and other phenomena on the planet. All of these are enormous data sets, and we really need to start getting those enormous data sets and putting them into still larger data sets. So I see one of the key gaps here as being the ability for humans to manage these enormous data sets, and the amount of data that we can collect now is beyond the understanding of humans, I actually think. There are just so, you know, you can sequence terabytes of DNA, But is there any human that can actually apprehend that information? I don't believe so.
Let me ask you one more question then. But that's true, and I think the science that we can bring to bear on this, and thinking differently about that, and helping us to actually visualize the life that's around it and for which we depend, and how we're really affecting it. But don't you think that we should have more respect and begin to really learn from the original peoples, the First Nation peoples, the Aboriginal people around the world?
Yeah.
Because they, in some way, they actually can hold and understand enormous complexity and connections.
I have a slightly controversial viewpoint about this, and it's based on the knowledge that as humans spread around the world, everywhere they went led to extinctions of local flora and fauna. It doesn't matter what migration you talk about, whether it's Aborigines into Australia, Amerindians into the Americas, the colonisation of New Zealand or Mauritius or Easter Island, or anywhere that humans go, we've led to a whole series of extinctions. Now, I actually believe that indigenous peoples around the world have learnt from that. They remember that when they first arrived in a place, in the place that they now live, that place was a much nicer place to live than it currently is. And they recognise that it was their ancestors' own actions that changed the place from what it used to be to what it is now. And as a consequence, all of the surviving indigenous groups all have this idea about the earth as a nurturer and a mother, because they recognise what happened in the past and they don't want it to get any worse. And those cultures that did not recognise that are no longer here. So yes, I'm not suggesting that all humanity should become Yanomami Indians, or that we should all become hunter-gatherers again. I don't think that's going to happen. But what we can do is learn about their attitudes, because we are not dinosaurs. We can learn from our history. We know about our history. We can reconstruct all of the things that have happened to all of the civilizations that have collapsed in the past. We know why they collapsed. We know when they collapsed. And we know which civilizations or cultures survived that collapse and how they did so. And in every single case, survival of those cultures was because they changed what they did, and they recognized what they had done in the past, and they stopped doing it. That's our challenge.
Thank you, Michael. Wonderful.